Euclidean, yeah, no, it definitely looks like Euclidean is the winner. Okay, before we start, someone's asking how to work out cumulative frequency. Let me quickly see. If you have, where can I do it now? Just quick, if you have like your interval, say it's 0 to 10, and then 11 to 20, and then 21 to 30, say those are your intervals, whatever they, what's the word, represent. And then you have your frequency. So say this is like ages, there are 3 people, and that in those ages, 7 here, and then 21 people there. Then the cumulative frequency, let me just move the phone a bit. I don't have a lot of space now, I'll just call it CF. The cumulative frequency is when you are literally adding the frequencies together. So your first cumulative frequency is always the same as the frequency, and then you're going to say cumulative frequency plus the next frequency. So 3 plus 7 is 10. And then you're going to take your cumulative frequency again plus the next frequency, so that's 31, and then you just keep doing that. So every time you take the previous cumulative frequency and you add the next frequency. I just want to turn the music down quickly. For grade 10 paper 2, I think so. I just need to find out about some of my plans, but I will keep you guys posted. Just keep an eye on my profile whenever I... Sorry, let me just turn down the music. Whenever I decide to go live, I put a live event on my profile and I make a video on it or about it, so you will find out. Okay, I'm just going to give it 2 more minutes. I just want to quickly finish my coffee, and I'm getting my Euclidean geometry worksheets ready here. I printed a whole bunch of stuff. So now that we've decided on Euclidean, so this is the winner, guys. We're going to be doing Euclidean geometry. If you need help with any of the other topics, there are loads of videos on my YouTube channel. There aren't, I'm actually not sure if there are videos on analytical, but there are definitely videos on trig graphs, and 2D trig, and then also lots of videos on Euclidean geometry. So you can go find a bunch of stuff over there. Okay, let me just get my worksheets ready here. Okay, Euclidean. I have a basic worksheet, which isn't really basic, that's just the name of it. So we'll work on these ones, and then I have an advanced worksheet, which it looks like this, these types of questions. So we'll just do a few of the more basic ones, and then we can look at the more difficult ones. Do I have videos on angles of depression? I'm not actually sure. Do you mean for 2D trig? Angles of inclination, angle of depression, angle of elevation, angle of depression. I have videos on 2D trig. I'm not sure about analytical, guys. I'll have to go check. I might not have been recording my lessons at that time. I basically started recording my lessons because we had one group coming in at school on one day and another group coming in the next day. So instead of teaching the same content twice, I would just teach a lesson, record it, and then send it to my kids, and they would watch it at home on the same day, so that we could actually cover all the content instead of doing like one day on, one day off kind of thing. But I think when we were doing analytical, they were all at school, so I might not have recorded those ones. Memorizing Euclidean theorems. Yes, definitely. You do have to be able to, or you have to know them well enough so that you can actually identify when you have to use them in a question. So what I do have on my Google Drive, if you click on the link in my bio and you go to grade 11 maths notes, or just, yeah, I think it's called grade 11 maths notes, the link that you must click on then, there is a geometry summary note where it summarizes all of the geometry that you should know up until this point, including the circle geometry, and it has all the correct reasons as well. So that's quite useful if you want to go take a look at that. Okay guys, we are going to get going. Let me you're welcome. Just get a new page here, and I just want to turn this slightly. I just do have to apologize about my setup. I'm literally, I don't have like a ring light and all of that tech stuff, so my books are just balancing, my phone is balancing on a pile of books, and I'm having to hold it with my one hand. So, yeah. That is just the situation. Okay, guys, let's get going. So here, they're saying that in all of these questions, so there are 12 of them. We're not going to do all 12. I want us rather to spend some time on the more difficult ones, because those are usually the ones that are asked. So they're saying here, O is the center of the circle in all of them. All right, so whenever we see O, then we know that that is the center of the circle, and they're finding us to determine, or they're asking us, sorry, to determine with reasons X, Y, and Z. Okay, now, they're saying each question counts 6 marks, except questions 8, 10, and 11, which count for 8, and question 12, which counts for 16. All right, so there's a lot going on in question 12. I'm just going to do like selected questions. We're not going to do all of them. I think we'll do numbers 2, and then we'll do 4 and 6, and let's do question 9, and then we can do 11, and then we'll do question 12. Okay. Now guys, someone did already ask, I don't know if people have been joining since then, but it is important that you know your theorems, because if you don't know your theorems, you won't be able to recognize them and you won't be able to apply them. So I think a lot of people, when they're studying for Euclidean geometry, they just kind of go straight into a question without actually having memorized the theorems, without having practiced actually identifying the theorems. It is important that you do that first, because otherwise if you just go to a mixed question and you don't actually know your theorems, you're going to feel so lost and it's just going to be so disheartening. So that's what I suggest, is that you first make sure that you know all your theorems and the correct reasons. Guys, reasons are super important. I mark maths paper 2 for matric at the end of the year, and we take off marks if your reasons are not correct. Okay, you have to have the reasons that are in the CAPS document. In the exam guidelines, you can find them. That's also saved on my Google Drive. If you go to grade 12 and then exam guidelines, it's the same reasons for grade 11 and grade 12, or you can just Google. You can just Google CAPS, maths, geometry reasons, whatever, and it should come up. Okay, so let's start with number 2. They're saying, yes, I am hoping that TikTok will record this and then I'll post it to my YouTube, definitely. Okay, guys, so for this first one, number 2, we're not going to do number 1 now, we'll do number 2. Another hint that I can give you is to first, before you actually start finding all of the values, these ones are quite simple, so you can actually just kind of jump into it. But if it's a very complicated situation, you'll see in the more advanced ones, just quickly familiarize yourself with the picture, with what is actually going on. If we're looking at this, we see that we have the center there. We have E, H, G, F, or E, F, G, H. I suppose that's better. That's alphabetical order. And that is a cyclic quad, right? We can say that straight away because the 4 vertices of that quad lie on the circumference of that circle. So E, F, G, H is a cyclic quad. Now we notice, okay, we have 118 and there we have X, or we're trying to find X. So that is going to be, or these two are opposite angles of a cyclic quad. Now that is something that you must know, guys. You need to know that the opposite angles of a cyclic quad add up to 180. All right, so you need to know that if that is 118, X is going to be 180 minus 118. Okay, so that is how we're going to find the first one. So let me just write here, number 2, X is equal to 180 minus 118. You don't have to write that working down. It's fine. You can just write the answer actually. So x is then 62 degrees, which you can obviously calculate on the calculator if you want. The reason is very important, guys. Like I said already, opposite angles of cyclic quad. Oh, sorry. Okay. That usually will count 2 marks, possibly only 1. It depends on how many times you've done this question, this type of calculation. So you'll probably get a mark for x and a mark for the reason. Sometimes, especially in matric, they give 1 mark for the value and the reason together. So even if you have your 62 degrees, but you don't have that reason, you might not get the mark. Okay, so that's important. Okay, so we found x. Another thing that I can suggest is as soon as you find something, fill it in on the diagram. Right, a test or exam, you usually are allowed to take that home with you. So you can highlight, you can make any sort of notes on it. It's yours to work with. All right, the next thing is that we need y. Now, if we turn the page around, thank you, Palisa. Okay, if we turn the page around, I think it's a bit easier to see what we have to do to find y, right? If we're looking at y is subtended by this arc. Right, oh, sorry, it's a bit difficult to do this one-handed, but that arc, which is arc EG or EHG if you want to call it that, is subtending angle Y at the center. EHG, that arc, is subtending angle X, which is 62 degrees at the circumference. Now again, that's something that you need to know, that the angle at the center will always be equal to double, 2 times, the angle at the circumference if they are subtended by the same arc or the same chord. So if, for example, there was a line drawn in there, they would be subtended by the chord. In this case, there's no line there, so we just say that it's subtended by the arc. Right, so y is going to be double 62. Again, you don't have to write the working. I am just going to do that, but you can just write the answer. Yes, it will be recorded. All right, and now the reason here is quite long. It's a bit of a schlep to write this down, but guys, you have to. So angle at center equals 2 times angle at circumference. And you have to write the whole word out. Please, if I can do it, you can do it. Okay, so y is then 2 times 62, which is 124 degrees. Okay, again, we found that, so now we fill it in. Okay, last one, to find z. Now, there are multiple ways in which we can find z. Is that we use the more obvious one, I suppose. It doesn't really matter. It's up to you which one you want to use. But I'm going to use angles around a point because z and y both lie around point O, so together they should equal 360 degrees. So we're going to say that Z is going to be 360 minus 124. 360 minus 124. Let me just quickly, I suppose I should do that in my head, but I'm lazy now. Okay, so Z is going to be 360 minus 124, and the reason for that is angles around a point. So that is 236 degrees. Again, you don't have to write the working down. You can just write the answer. So now actually there are 2 reasons that you can write here. So you can write angles around a point, or you can just write revolution, which is a bit shorter. That's also fine. You'll get the mark if you write either of these 2 reasons. Okay, so number 2, that was a nice slow introduction. Okay, number 4. Again, we need to find x, y, and z. Again, guys, let's just quickly see what are we working with here. We have P, Q, R, and S. Those 4 points lie on the circumference of a circle. So these 4 points form a cyclic quad. And guys, if you want, you can even take a highlighter and you can literally especially when we're getting to ones that are a bit more complicated, you can use a highlighter or a colored pencil or colored pen or whatever, and you can actually draw in that cyclic quad. All right, to remind yourself that that is a cyclic quad. Sometimes the cyclic quads are a bit difficult to spot. All right, you'll see when we get to the more difficult ones. So now we need to find x, which is this angle over here. Now, guys, if they're asking us to find x, y, and z, usually they want us to find them in that order. So we're going to find x first. Now, x is an interior angle of the cyclic quad. Do we have the opposite angle? No, not yet. We're supposed to only find z at the end. So we're supposed to find x before we find z. Now, here, this angle on the other side of z, 69 degrees, that is actually the exterior angle of this cyclic quad, which is also a theorem that you need to know. You don't have to be able to prove it, but you need to be able to use it. So the exterior angle of a cyclic quad, and guys, it's important that you understand that an exterior angle is an angle that's on the outside of the cyclic quad, obviously, but it has to be made by one of the sides that has been lengthened. All right, so QR is actually a side of the cyclic quad that has been extended past the circumference of the circle, and that forms an exterior angle. If we had a line like this, right, I'll erase that now, and we had that angle there, that big angle is not an exterior angle of the cyclic quad because it's not formed by a side of the cyclic quad that has been lengthened. Okay, let me just erase that. So that's important, guys. So 69 degrees in this case is an exterior angle of the cyclic quad, and the rule is that the exterior angle of a cyclic quad is equal to the opposite interior angle. So the best way to find that is you look at the angle that's next to the exterior angle and then the angle that's opposite that one. Those two will be equal. So x is going to be equal to 69 degrees. Okay, so number 4, I'll answer the question now. I am seeing that there are some questions. Let me just write this down quickly. So the reason here is ext, you're allowed to write that, exterior angle of cyclic quad. Okay, so someone asked which theorems you have to be able to prove. I posted a TikTok video on that a couple days ago, so just scroll down on my profile. I did list them all. I wrote them down and they're listed. And then, will you lose marks if you don't solve the angles in order? Not if they don't specify, all right? So in this case, they didn't specify, but we are practicing it like that because they probably will specify. So I think if they've given you angles in alphabetical order, the intention is usually that you have to solve them in that order. But what they actually usually do is they ask them as separate questions. So they'll maybe do like 4.1, find x, 4.2, find y, 4.3, find z. So then you're actually kind of forced to find them in that order. All right, so we got x is 69 degrees. There we go. All right, now y. Now if we look that we have x, which is 69, x is subtended by this arc now, right? QRS subtends the 69 degree angle at the circumference, but QRS also subtends y at the center. And we know that the angle at the center has to be double the angle at the circumference. All right, so it's the same reason as what we did at the top to find y. So y is 2 times 69 degrees. Your reason again, guys, every time you use this, unfortunately, you have to write the whole reason down. So angle at center equals 2 times angle at circumference. You guys are so polite. You're welcome. Okay, so 2 times 69 is at 138. Right, 138 degrees. That is the size of y, 138. Okay, last one, we need to find z. Now we have 2 options here. We can use angles on a straight line, right? Yes, 138. You can use angles on a straight line. We can say that z is 180 minus 69 because of angles on a straight line. Or we can also use opposite angles of cyclic quad, in which case we'll have the exact same working because we remember that opposite angles of a cyclic quad add up to 180. So we're going to say z is 180 minus 69, and then your reason would be opposite angles of a cyclic quad. So it's up to you which one you want to use. The working and the answer will be exactly the same. So you can say angles on a straight line, or you can say op angles of, I'm just going to squeeze it in here at the bottom, cyclic quad. Oh, I'm still work that out. So 180 minus 60 is 120. So this is 111. Is that correct? Yeah. Okay. Just let me know if you guys have any questions as we're moving along. I am able to see the comments, so I will just answer them as I get a chance. Okay. Number 4, also not too bad. Some basic theorems there that we've applied. All right, let's look at number 6. Now, the problem that I have with number 6 here is that they haven't actually told us that we have tangents here. All right, they actually are supposed to tell us. So if we're looking at number 6, QFP is a tangent and RHP is also a tangent. All right, they haven't told us that. I know because I've worked through this worksheet before that we are supposed to assume that they're tangents, but guys, in a test or exam, you actually can't assume that. They do have to tell you that it's a tangent, and if they haven't told you and you want to use tangent theorems, then you actually need to first prove that it's a tangent before you're allowed to do that. So I'm just quickly going to use 2 different highlighters here. I'm going to highlight the one tangent, and guys, if we know that we have a tangent, right, and we have an angle between a tangent and a chord, all right, so x, for example, we know that that angle has to be equal to the angle, oh, I made a mark there now, this angle between the tangent and the chord has to be equal to the angle subtended by this chord in the alternate segment, so 65 degrees over there. So there we already have x. All right, x is 65 degrees because of tan chord theorem. There we go. That wasn't too bad. Okay, tan chord theorem. Let's take a look. What else is going on here? We have another tangent, right? PHR is also a tangent. Oh, there we go. That's also a tangent. All right, so now we know that again, because of tan chord theorem, the angle between the tangent and the chord is equal to the angle subtended by that same chord in the alternate segment, so on the other side of the chord. So y is also equal to 65 degrees, also because of tan chord theorem. I'm going to show you another method of doing it, if you didn't want to use tan chord theorem for both of them. Now guys, often with these questions there will be multiple ways of finding the actual answers, which is great. Then it doesn't matter what method or what reason you write down, as long as it's correct, you'll get the mark. I do hope that we all remember that if you have 2 tangents drawn from a common point outside the circle, so from point P, then those 2 tangents will be equal in length. Right, so FP will be equal to HP. All right, just from the point outside the circle to the point of contact, not the whole thing. All right, because you can lengthen this for as far as you want, and this one might have stopped over here. So that theorem only says that 2 tangents from a common point outside the circle to the point of contact, right? So where the tangent touches the circle, those will be equal in length. So what we actually have, you're welcome, Palesa, I'm glad. So what we actually have here is an isosceles triangle, right? We have that FP is equal to PH because of tangents from common point. Now, if you are finding x using tan chord theorem, right, that x is 65. So there we have 65. And you know that this is an isosceles triangle, then we know, remember that opposite or angles that lie opposite equal sides in an isosceles triangle are also equal to each other. So you actually could have used that, the fact that it's an isosceles triangle, to solve for y. This is a Pilot friction pen that I'm using. Okay guys, so if you wanted to use that, instead of using tan chord theorem to get y as well, you could have said FP is equal to PH because of tangents from common point. And then y is equal to 65 degrees because of angles opposite equal sides. Okay, so that's obviously more writing, but I'm just going to write that down just in case so that you could see the correct way of writing it. Okay, sorry, let me just readjust here a little bit because the phone is pointing downwards a bit. Okay, so you would have to say FP is equal to PH tangents from common point. Therefore, y is equal to 65 degrees. Angles opposite equal sides. Guys, you are not allowed to write, I'm not sure about IEB, but in DBE, in caps, you are not allowed to write isosceles triangle. Alright, you have to say angles opposite equal sides. That is the reason for when you're working in an isosceles triangle. Okay, so we have x and y. We now still need z, and I hope that you guys can recognize that z, again, is an angle at the center, which is subtended by FH, by that chord. So z is at the center, so z is going to have to be double the angle that is at the circumference, which is 65. All right, so z is going to equal 2 times 65 degrees, which you don't have to write that working. You can just write the answer straight away. So that is 130 degrees, but you do have to write the whole reason. So angle at center equals 2 times angle at circumference. All right, there we go. Number 6 is done. Okay, I wonder if we should maybe leave out 9. Yeah, let's skip number 9. I want to get to the more difficult ones. Let's do 11 quickly because 11 is working with a theorem that is not often tested, but if it is tested, obviously you want to be able to know what to do. Alright, so for number 11, we have, again, let's first see what we actually have, what we're working with. So there we have the center. They told us that O is the center of the circle. Now we have a line from the center that is perpendicular to this chord, PQ. And that is theorem 1, guys. If you have a line from the center of a circle that is perpendicular to a chord, it bisects the chord. It cuts the chord in half. That means that this part, PR, is equal to QR. And good, look, there we have the value of x. If this is 20, we've just said that this side, or this part now, the side of this triangle, I suppose, is supposed to be equal to that one. These two parts are equal. So x is 20. All right, there we go. We've already found that answer. So for 11, x is equal to 20. Now, guys, it's not 20 degrees, please. We need to pay attention to what we're finding. X is a length of a line here, of a side. So x is 20. You can say 20 units, but don't put 20 degrees, please. It's not an angle. So if you want to put a unit there, you can just say units. And the reason for that is line from center perpendicular to chord. All right, that is important. Line from center perpendicular to chord. Okay, so we found x. Let's take a look at y. We need to find y. Now, y is this line, right? OP, which is a radius. Okay. Now, guys, if we want to, and I think most of you could probably identify that we have to use Pythagoras here, right? We have a right angle triangle, but now the problem is, so we have that 20, but the problem is we don't have that. We don't know what that length is. And in fact, we're supposed to find z after finding y. So we're supposed to find this length first, and then that one. So guys, what I want you to notice is that y is a radius, and OS is also a radius. So OP is supposed to be equal to OS. Now what is OP? OP is y. that is supposed to be equal to OS, which is what? Z plus 8. Okay, now does that help us? Remember, if I want to use Pythagoras here, I actually need to know what Z is. Now, we're not going to find a value for Z because, like I said already, Z comes after Y. We're supposed to find Z, the actual length of Z, the actual value. We're supposed to find that last. But what we can do is we can make Z the subject over here, right? We can say that Z is actually equal to Y minus 8. Z, this part of that line, is equal to the radius, which is Y, right? Minus that bottom bit. So Z is equal to Y minus 8. Okay. So that's tricky, guys. That is something that's quite difficult to do. I'm just going to repeat. The reason for why I'm doing that is because I have to work with Pythagoras in that right angle triangle OPR in order to find Y. But I can't find the length of Y if I have a Y and a Z in my working. Alright? I can't do that. So I need to somehow express Z in terms of Y, so that now when I set up an equation using Pythagoras in this triangle, I only have Y's. I don't have a Z as well. Alright, because if we have a Y and a Z, we can't possibly solve for Y. Okay, so let's see how that works out. I'm going to first just say that Z is equal to Y minus 8. And the reason for that, guys, basically is just because these two lines are both radii. So I'm just going to say that Z is equal to Y, the whole radius, minus 8. That part, that will give me Z. And the reason is radii. Alright, so Z is equal to Y minus 8. Because of radii. Therefore, I can now actually work with Pythagoras in this triangle. So I'm going to say y squared, right? The hypotenuse squared is equal to the sum of the other side squared. So y minus 8 squared plus 20 squared. And then I'm going to solve for y in that equation. All right, so y squared is equal to y minus 8 squared plus 20 squared, and the reason is Pythagoras. Okay, and now you can see that this is a quadratic equation with y's in it. Okay, so I'm just going to leave that y squared where it is for now. Guys, there is a shortcut for squaring this bracket out, but if you are not sure of that shortcut, I suggest just writing them down like that. The two brackets, because a bracket multiplied by itself is the same as the bracket squared, plus 20 squared, which is 400. Thank you. Now I'm going to just multiply it out. Y times y is y squared. Negative 8 times y is negative 8y. Times negative 8 is another negative 8y. And then negative 8 times negative 8 is 64. Plus 400. Now guys, what's going to happen here is that we have a y squared on both sides, right? Which is actually quite nice because they are going to cancel each other out. Because if I now was to say, okay, I'm going to move this y squared over to this side, it's going to become negative y squared. So I'm going to have y squared minus y squared. So that's just going to leave me with 0. So the y squareds actually cancel out in this case, which is really nice. So what I'm left with here, I have the 0 over here, if you want to look at it that way. I have negative 8y minus 8y, which is negative 16y, plus 464. So this is actually just a linear equation, so let's move the y term to the other side. So it's going to become positive 16y. Thank you so much for that comment. That's very kind of you. Alright, so this moves and it becomes positive 16y, and that is equal to 464. Alright. And now, guys, we need to just divide by 16. Okay, now, I must admit, I'm not sure what that is off by heart. So let me just quickly work that out. 464 divided by 16 is 29. So y is in fact 29 units. All right. Okay, so now we found y. Y is 29. Now guys, that is quite helpful because now we need to find z, and if y is 29, z is just going to be 29 minus 8, right? Y minus 8, so 29 minus 8. Okay, so therefore z is equal to 29 minus 8, which is 21 units. Okay, good stuff. So that's an interesting question, guys, and they tend to ask these types of questions when they want you to use theorem 1 and theorem 2. It was actually theorem 1, and then theorem 2, I suppose, is a converse of theorem 1. So the one that we've used just now is that a line from the center perpendicular to a chord bisects the chord, but then it also works the other way around. If you have a line from the center of a circle that bisects the chord, then it is perpendicular. So those are the two theorems, the first two. And whenever you're working with those, you're actually working with lengths of sides. Okay. Now, I'm going to skip question 12 as well. I really want us to get to these advanced questions because I think that is why people struggle with Euclidean geometry a lot. I think these types of questions that we've done now are not too bad. You can kind of manage to do them if you know your theorems well, but the next stuff, the more difficult ones, are often the ones that people struggle with. So let me actually just quickly tear this page out. Sorry, I'm working with one hand because I'm holding my phone in the other hand, so it's a bit difficult to maneuver. All right, advanced target worksheet. Now guys, for this very first question, you can already see that there's a lot going on, and there are 5 questions that we have to answer. We're going to work through them step by step. Before we get going, I just want to say to everyone that's here, this year, I recorded every single one of my Euclidean geometry lessons that I did with my own grade 11 class at the school that I teach at. So they are all on my YouTube, and that was right from the start when we revised the stuff that we did in grade 10, because we do some Euclidean geometry in grade 10 already, all the way through the new proofs that we had to do, where we revised the previous proofs that we did last year already. The new proofs are there, as well as a lot of marking of homework, where I put, it's just like this kind of situation where I put the question on the board or under the camera like this, and I talk through it. I make notes and all sorts of indications on the diagram, and I explain it step by step. Alright, so there is a lot of stuff there. If we maybe only get through this one question in the half hour that we have left, or 40 minutes that we have left, don't panic. There's a lot of other stuff that you can go watch on my YouTube channel. Okay, so number 1. Guys, like I said, when we have stuff that's like this, there's a lot of stuff going on. It's important that we first identify all of the information that we actually have, that we first just, what's the word that I used earlier? That we just, sure, I can't remember the word now. My English has left me, Friday afternoon vibes. That we first just kind of see what's going on here. All right, we just make sure that we know, okay, do we have a tangent? Do we have diameters anywhere? What's going on? What cyclic quads do we have? Blah, blah, blah. All right. So I like doing that before I even start working through the question. So I'm going to model that now with this one. Okay, so they're saying O is the center of the circle. Now, guys, they haven't even drawn the full circle, right? They literally just given us the semicircle, all right, which is very interesting. So they're saying which passes through P, Q, T, and S. Now, guys, if they're saying that the circle passes through P, Q, T, S, that means that it's a cyclic quad. All right, these 4 points, even though we can't see the whole circle, they're telling us that the circle passes through those points. So we know already that P, Q, T, S is a cyclic quad. All right, so it's important that you recognize that right from the start, because you're probably going to have to use that at some point. Okay, PS and QT are produced, they are lengthened to meet at point R. Now guys, basically what that is telling us actually is that PSR is a straight line. So here we could use angles on a straight line if we wanted to, and same thing here. They're telling us that this is a straight line. Okay, that's actually what that information is telling us, that PSR and QTR are actually straight lines. Then RU, where's RU now? RU is this line over here. PT is that line there. And QS, that line over there, intersect at V. Alright, so they're telling us that those three lines go through point V, all three of them. W is the midpoint of PT. Now guys, that is important. Notice that they haven't actually indicated that on the diagram. W is the midpoint of PT. Is the midpoint of PT. So they're telling us that PW is equal to WT. Now, if I put that on here, on the diagram, it's going to look a little bit busy. So I'm actually going to write it underneath. Not going to go live with anyone now, guys. Just want to focus on this. Okay, so PW is equal to WT. So let me just write that at the bottom so that we have it all the time. Okay, and that is given. When they say that W is the midpoint of PT, they're telling us that PW is equal to WT. Okay, and guys, another hint is they're probably not going to give you information if you're not supposed to use it at some point. So it's important that you identify all the information right at the start. Okay, and then they're telling us finally that TPQ is X. TPQ, another thing that they didn't put on the picture, that angle P2 is equal to X. Okay, first question. Now guys, before we actually go to the first question, what I'm just noticing here now, right? They told us that O is the center of the circle. So that means, and they're telling us that P and Q lie on the circumference of the circle. So that actually means that PQ is a diameter of the circle, right? Now, do we remember that a diameter of a circle always subtends a 90-degree angle? So if PQ is the diameter, then that means that S1 is going to be 90 degrees. I'm filling that in so long, all right? And then PQ again is the diameter here, so it subtends a 90-degree angle at the circumference there as well. So we already have two 90-degree angles. Yeah, sorry, my phone overheated, so all of the apps just closed suddenly. It's never happened before, so I had to find my old phone quickly. Thank you, Palesa. I'm glad about that. Let me just check if I put... Just waiting for people to join.
Do these kids appreciate you?
I think so, yeah. They sound very appreciative.
They must know they're taking my time with you. So they better appreciate it.
They're going to do well in the exam.
Yes, I want to see results. Post results. Tag that math teacher. All your results on TikTok. Thanks.
Wow, look at this promotion happening here behind the scenes. Thank you, guys. No, he's fine. He doesn't actually mind. He's busy with his own stuff there. Okay, we are on 87 again. I think we can get going. Guys, so sorry about that, about it just going off. My phone was overheating, so it just closed all of the apps very suddenly. So we're having to start again 2 weeks ago. Okay, guys, we're going to get going again. Sorry, the quality is not great or not as good on here because it's my old phone, but the new one is, yeah, not usable at the moment. What I'm going to do is I'm going to edit together the first part and the second part, and I'll crop out like all the irrelevant stuff in between. Okay, let's go. So, guys, we were busy on this question. And we had just discussed that before looking at the actual questions, where is V? V is this point over here with all the 6 angles around it. So that is point V. Okay, so guys, we were discussing that since they told us that O is the center of the circle and P and Q lie on the circumference, we can see that POQ is the diameter of the circle. So it subtends, don't worry, it subtends a 90-degree angle at S1 and a 90-degree angle at T3. All right, so we can see that immediately. And guys, it's nice if you're actually able to find things like that before even really jumping into the questions, because we know that once you start jumping into the questions, you know, yeah, you can be a bit, what's the word that I'm looking for now? It's easy to miss things if you haven't like orientated yourself. It's pure maths. All right, so guys, prove that SVTR is a cyclic quadrilateral. Now let's see. SVTR is this quad over here. Now, something that I can also suggest is that you take now a different color pen, because I have, or highlighter, I've highlighted this in purple, right? Will Maths Lit students do this? No, I don't think this is in the Maths Lit syllabus. I am now going to highlight this quad that they're asking us now to prove is a cyclic quad. All right, just so that we can get a nice idea of what is going on here. So that is now what we are supposed to prove. Now guys, there are 3 ways in which you can prove that a quad is a cyclic quad. The first one is to prove that opposite angles, one pair of opposite angles, you only have to prove one pair. To prove that a pair of opposite angles add up to 180 degrees, because we know that that is one of the properties of a cyclic quad, that opposite angles add up to 180 degrees. Another one would be to show that an exterior angle of the quad is equal to the opposite interior angle, because that again is a property of a cyclic quad. So we can do that. Or we can prove that here, for example, SR, which is one of the lines of the cyclic quad, the quad that they're asking us to prove is cyclic. If we know that, for example, V2 was equal to T1, right? So those 2 angles there. So if we have one side, it can be any of the sides, any of the 4 sides of the quad. If we could prove that it was subtending equal angles, then that would also make it a cyclic quad. All right, the summary of those 3 methods is also in my geometry summary note, which is on my Google Drive, which is in the link in my bio if you click on there. All right, so let's see, guys. We need to try and find some information. Now, what we already found here was that S1 was 90 degrees. Now, won't that make S2 and S3 together also 90? Because remember, they told us by saying that PS and QT are produced to meet at R, they were telling us that this is a straight line. All right, so they're telling us that this is a straight line. So if S1 is 90, that means that that angle is also 90. All right. Now, guys, we actually have it. There we have enough information, because T3 is 90 degrees, right? Remember, because it's subtended by the diameter of the circle. And T3 now, which is 90, is equal to the opposite interior angle, which is also 90. Would you look at that? As easy as that. If you wanted to, you could also say that T1 and T2 is also equal to 90 because of angles on a straight line. And then you have opposite angles of cyclic quad add up to 180. Can you go to the bathroom? I see one of Mr. Webster's students are here. Yes, you are free to go to the bathroom anytime. All right, so guys, let's write all of that down. We're going to say S1 and T3 are both equal to 90 degrees because they're subtended by the diameter. Now, the reason for that is angle in semicircle. Then I'm going to say angle S2 plus S3, or if you want, you can say angle RSQ, that's also perfect, is equal to 90 degrees because of angles on a straight line. And then I'm going to say, therefore, T3 is equal to RSQ. Therefore, SVTR is a cyclic quad, converse exterior angle of a cyclic quad. Okay, I'm going to write all of that down, and then we'll just go over the steps again. Right, so 1.1. S1 is equal to 90 degrees, and T3 is equal to 90 degrees angle in semi-circle. Cassius, yes, you said ma'am. Can I help you? Okay, so that's the first bit. So then we said that S2, so now you can write S2 plus S3 if you want, is equal to 90, or you can also just say RSQ. That's the same angle, RSQ. The reason there is angles, angles on a straight line. Therefore, T3 is equal to S2 plus S3. And there's no reason for this because we've just proven it, right? We just have it actually written down there that T3 is 90 and S2 plus S3 is 90. So therefore, they are equal. All right, there's no reason for that. I'm just kind of summarizing what I've just written down. Therefore, SVTR is a cyclic quad. Now, guys, the reason here is very important, okay? They didn't tell us that it's a cyclic quad. We are proving that it's a cyclic quad. So when we are doing that, we're going to write the same reason as when it was, if it was given that it was a cyclic quad, but we're going to say converse in front of that reason. So converse exterior angle of cyclic quad. Let me just move that up. It's a bit off screen like that. Converse, that is very important. So the normal cyclic quad reason, but you put a converse in front of it if you're proving that it's a cyclic quad, or you can write exterior angle equals, it's actually opposite interior angle, but interior opposite angle I suppose is also fine. But guys, if you're not using the word converse, you can't use cyclic quad in your reason. Okay, so converse and cyclic quad must always go together. If you just say exterior angle equals opposite interior angle or interior opposite angle, then you don't have to write converse. Okay, but I just teach my students, just use converse and then the normal reason. Okay. There we go. It's a cyclic quad. Now, guys, the important thing now, which I think a lot of people don't realize or are unable to apply, I'll answer your question now about the converse, is that if you have now proved that something is a cyclic quad, yes, when you prove it, you have to write converse, yes. You can now use properties of a cyclic quad for that quad. And that is something that people really struggle with. Why is my triangle skew? I'm not really sure what you mean by that. Okay, so now we are able to use properties of a cyclic quad. So now the thing that we need to realize is that if this is a cyclic quad, we can actually draw a circle through those points. Okay, it's difficult to do that. All right, I'm gonna just, sure, I feel like if I do that, it will make things a bit daunting. So guys, what you can just think is that you will actually be able to draw a circle going through all those points. So now we need to actually realize that RT will be a chord of a circle. So I can now use angle subtended by a chord, all right? SR is also a chord of this imaginary circle, the circle that we can't actually see, all right? SV is also a chord and VT is also a chord. These 4 lines, the 4 sides of the cyclic quad, are actually chords. All right, I'm not going to write that down there now because it's going to make things a bit too busy. I try to avoid making my diagrams too hectic because it can be a bit overwhelming. All right, but that is important, guys. That means once you have prove that something is a cyclic quad, you can then use the 4 sides of that cyclic quad as chords, which means that SV, for example, subtends 2 angles, R2 and T2. And because we proved that this is a cyclic quad, R would have to lie on the circumference of the circle, and T would also lie on the circumference of the circle, and S and V, meaning that you could use angles in same segment to say that R2 is equal to T2. All right, same thing here. VT is also a chord of the circle. Sorry, I'm reading your comments, so I'm getting a bit distracted. VT is also a chord of this imaginary circle that we can't see, but that we could draw in. All right, if we were brave enough, you can definitely draw one in. So VT is a chord, meaning that the angles at the circumference of that circle, that imaginary circle now at those 2 points, will also be equal. So S2 will be equal to R1. So guys, it is a good idea that once you've proven that something is a cyclic quad, to fill these things in, all right? Because then you can actually use them going forward. So I'm using the same kind of symbols to indicate that they are equal. Same thing here. RT, again, is a chord of this imaginary circle now that we could draw in there. So that means that... What are you guys talking about? My pen? If you have time, could you maybe also do a video live on grade 11 stats? I will think about it. Okay, let's just quickly get back to this. RT is a chord, so it subtends equal angles. Now, guys, that is... Okay, no, never mind. I was thinking for a second that it's the 90-degree angle here. All right, so that means that V3, I'm going to use 2 little arches for that one. So V3 is going to be equal to S3. And then we have one last chord that we haven't looked at, SR. So SR subtends T1. Let's use a star for that one. And V2. Guys, we might not have to actually use all of these pairs of angles now, but I'm just filling them in. All right. And again, I'm doing that because in 1.1 we proved that SVTR is a cyclic quad. So that means that all 4 of the sides of the quad are chords of the quad, all right? And that there is a circle there through those points. So all of the angles that are subtended at the circumference will be equal to each other. All right. 1.2, state with reasons 2 other angles equal to x. Now here we have x, all right? So this angle is equal to x. Now guys, this x angle is in the semicircle that we have over here, all right? We can just kind of visualize the bottom of that circle there. So if this angle P2 is x, that angle is subtended by QT, by that chord. Now does QT subtend another angle at the circumference of this semicircle? Let's take a look. I'm saying that P2, angle X, is subtended by QT. And do we notice that S2 is also subtended by QT? All right, so S2 is going to be equal to X. So now I can actually erase that arch that I put there. S2 is actually equal to X. But guys, we said that R1 is equal to S2, right? Because of this cyclic quad that we proved here. So there we have our second angle that's equal to X. S2 is equal to X, and then R1 is also equal to X. Okay, so I'm going to write that down. 1.2. S2 is equal to X, and the reason there is angles in same segment. Now I am just going to add on the side here. You don't have to add it on for marks, but if you are making notes of this, maybe just add it that this is from chord QT. All right, because P2 and S2 is equal to X. Okay, so now that is that S2 equal X there. But remember, because of this cyclic quad, VT subtends S2 at the circumference of the imaginary circle, and VT also subtends R1 at that circumference. So if S2 is X, then R1 must also be equal to X. And the reason for that is also angles in same segment, but just on the side, not for marks, just for understanding really. I am going to just write down that that is from chord VT. Guys, I just want to say something quickly about the pen that you guys are talking about. You're not allowed to write in this pen, and I wouldn't suggest that you write in this pen because heat removes it. So if I take this exam pad, for example, and I put it in my car, like in the window, or my car is very hot, then the ink disappears. So yeah, that has actually happened before, that someone wrote in an erasable pen and it literally erased, like the heat made the writing disappear. So yeah, you don't want that. Okay, two other angles equal to X, done with that. Now 1.3, prove that where's O now? Oh, WO here. Sorry. Prove that WO is parallel to TQ. These two now, we need to prove that they are parallel. Now guys, there are three ways in which you can prove that lines are parallel. Either you are going to use an F shape, all right? Do we see that we actually have an F shape there, right? Do you guys remember from like, yes, this is also a pilot erasable, thank you, Chicago West. Sorry, I'm just checking something here. Okay, what was I saying? Prove that WO is parallel to TQ. Okay. Now guys, if we notice this F shape over here, I'm just going to fill it in and I will erase it just now because I don't want this diagram to be too busy. But do we notice that we have an F shape over there? Now guys, in grade 8 you learn that angles that lie in an F shape, right? So those two, T3 and W1, those two angles will be equal if the lines are parallel. Okay, now when we have to prove that the lines are parallel, we're going to work the other way around. Now we actually need to first show that these two angles are equal, and then if they are equal, that means that the lines will be parallel. Now guys, we have that T3 is 90 already. So what we basically need to find out, yes, is whether W2, we could do W2 or W1 if we want to work with the F shape, is also equal to 90. Now guys, this is where this now comes in. Remember, they told us that PW is equal to WT. O is the center of the circle. Remember, if you have a line from the center of a circle that bisects a chord, which is what is happening here, because the line from the center of the circle, OW, bisects chord PT, right? They told us that W is the midpoint of PT. So W bisects this chord. Then this line is actually perpendicular to the chord. All right, that is the converse of theorem 1. Okay, yes, right angle, good. So we're going to say, guys, that OW is perpendicular to PT because of line from center or to midpoint of chord. Sorry, that's the actual wording. Line from center to midpoint of chord. That means that W1 is 90. And now if we have our F shape, which I drew in here, right? And we have that W1 is equal to T3. The only way for those two angles to be equal is if WO is in fact parallel to TQ. All right, and that is what they asked us to prove. So let's see. I must now try and remember everything that I said we must write down. Okay, 1.3. We are saying that OW or WO is perpendicular to PT, and the reason for that is line from center to midpoint of chord There we go. Therefore, W1 is equal to T3, right? Those two 90-degree angles. You don't actually have to write down that it's equal to 90, but just for understanding so that you remember what we're doing here. Therefore, guys, the only way for those two angles to be equal, right, if we have our F shape, those two angles would only be equal if these two lines are parallel, and that is what you learned in grade 8 already. Okay, so therefore, WO is parallel to TQ. It's parallel to TQ, and the reason for that is, now this is important, you're now going to have to say, remember the F shape, we call those corresponding angles. So you have to say corresponding angles equal. That is the reason for that. Okay, you're not going to say corresponding angles WO parallel to TQ, all right? When you are proving that lines are parallel by showing that angles are equal, you actually have to say corresponding angles equal. Okay, I hope that that is helpful, guys. Let's look at 1.4. This is grade 11. Okay, let's just quickly... Just give me a second. Let me just erase this F shape here because this diagram is a bit busy for my liking. Okay, let me just take that out and that over there. I just want to make sure that we can see our 90-degree angle. See that 90-degree angle over there. Okay, now we just found that these two lines are parallel. Guys, please add that in, all right? Usually if they're asking you to do something in 1.3, you're probably going to have to use that in 1.4 or further down. Okay, so it's important. We've now proven that these two lines are parallel, so we put that in. And guys, even if, this is also important, even if in 1.3 you have no idea how to prove that they're parallel, okay, you don't know how to do 1.3, you leave it out. What is important is they're saying prove that these two lines are parallel. So even if you can't prove it, you can use it going forward. So even if you can't prove that they're parallel, put in those lines, or those arrows rather, for the next question. All right, that is very important, guys. 1.4, determine the size of angle PQT in terms of x. Now, angle PQT, all right, PQT is this angle over here. We want to find this angle, PQT. Yes, basically you are assuming that they're parallel, but it's not really an assumption because they told you that they're parallel, okay? It's just, even if you're not able to prove that they're parallel, you can still use it going forward because they told you that they are. Okay, let's see quickly. We need to find PQT in terms of x. Now, guys, let's look at this triangle here, right? We have a right angle triangle there. T3 is 90. P2 is x. So PQT is going to be 180 minus 90 minus x. Yes, so that does simplify to 90 minus x. That is correct. I see the correct answer in the comment box. All right, so 1.4 PQT is equal to, and you don't have to write this whole working, you can just write 90 minus x straight away, but I'm just showing where this is coming from. So angle sum in triangle, 180 minus 90 is 90, right? So that is 90 and then minus x, correct. Okay, let's fill that in. Don't know, maybe we're gonna have to use that. All right, so this whole angle is 90 minus x. Okay, last question, guys. Prove that. Nice. OWVU is a cyclic quad. This very teeny little quad that we have over here. We now have to prove that that is a cyclic quad. Okay, let me see. I don't know if this yellow is going to show up nicely on camera, but let's fill that in. This is now the one that we need to prove is a cyclic quad. Is this the correct one? OWVU. Yes. I just panicked now. I thought I was coloring in the wrong one. Okay, so we now need to prove that this is a cyclic quad. That small little quad over there. Guys, just like I said before, there are three ways, in which you can prove that a quad is cyclic. All right, for this one over here, we used exterior angle. So we showed that T3 was equal to the opposite interior angle. So therefore, it's a cyclic quad. We might be able to use it again in this case. All right, so why should I prove? Okay, so OWVU. Now guys, if we know that W1 is 90, we do definitely know that W2 is also 90. Okay, so we're just filling that in so long. We can see what else we can do next. What else is going on over here? We need some more information in that proof, or in that quad, I mean. So we have that is 90. What I do need is I need to show that this angle is 90 degrees as well, because then I have opposite angles of a cyclic quad, or we again have exterior angle, all right? W1 is an exterior angle of this small quad here, and if we can prove that that is equal to the opposite interior angle, so this angle at U, then we've proven that it is a cyclic quad. Okay. So what we're going to have to do here, guys, like I said, usually if they're asking you to find something in 1.4, you're going to have to use that in 1.5. So now, and I do agree, guys, it obviously looks like a 90-degree angle. We can't just say that. We can't just assume that it's a 90-degree angle. Okay, we have to prove it somehow. So what we have here is we have x, and we have 90 minus x. Look at that triangle there. Triangle RUQ. Now remember, what are we trying to find? We're trying to prove that this angle at U, so angle RUP, is 90 degrees. We're trying to show that that is 90. Now guys, if we're looking at this outer triangle here, right, this angle is actually an exterior angle of this triangle. And we should remember also from grade 8 is when you learn it for the first time, that the exterior angle of a triangle is equal to the sum of the opposite interior angles. So if I add these two angles together, x and 90 minus x, which is, remember what we found in 1.4, I'm now using in 1.5. If I add these two angles together, it should give me the exterior angle, which is RUP. And isn't that great? Because RUP is then equal to x plus 90 minus x, which is 90 degrees. All right? And if this is 90 degrees and W1 is 90 degrees, then we can again say, because of converse exterior angle, that is a cyclic quad. Okay, so there we go. 1.5. RUP is equal to x plus 90 minus x, exterior angle of triangle, and we know that x minus x is 0, so we're left with just a 90 degrees. So there we go. There we have that angle is 90, and we have that W1 is also 90. We used that in the previous question already. So the exterior angle of this quad is equal to the opposite interior angle. All right, so therefore W1 is equal to RUP. Again, we don't need a proof for that because we've actually written it down already. Okay, so there I have that W1 is 90. Sorry, I mean we don't need a reason for that. So W1 is 90, I wrote there, and RUP is 90. Now I'm just summarizing those 2 points. Okay, so W1 is equal to RUP. Therefore, OWVU is a cyclic quad. And the reason now, remember when we're proving that something is a cyclic quad, we say converse exterior angle of cyclic quad. Oh, sorry, that's off screen. There we go. All right, so guys, that is all we have time for today. What I'm just going to summarize for you here is what we actually used that helped us in this question. The first thing is that we read through the whole paragraph. We made sure that we understood what each of these points of information actually meant. The whole page. Okay, I'll do that now. Let me just quickly talk through this. Then I'll zoom out so that you can see the whole page. Okay, so like I was saying, we read through the whole paragraph. Okay, that's always your first port of call, guys. You need to make sure, because they often do that, to check whether you're actually reading. You have to read through the whole thing. Make sure that everything that is written down there, you understand what it means and it is on the diagram. Then, once we actually started finding our things, our values, actually before that, we looked at the picture. After going through all of this information, making sure that it was all here, we looked at the picture and we actually identified what we had. We found that this is a diameter, so there's a 90 degree, there's a 90 degree. All right, those are two things that we could find straight away. That was quite easy. Another thing that we might have been able to find straight away, I just didn't notice it straight away, because they told us that these two are equal, we could have immediately noticed that OW has to be perpendicular to that because of line from center to midpoint of chord. All right, so that's another thing that you might have been able to identify before even starting to read through the questions. Then we did the first question, 1.1. After we proved that it was a cyclic quad, we know that we can now use properties of the cyclic quad. So we fill that in. All right, these are all of the angles that I put in. Now, guys, you could see that we didn't actually have to use all of the angles, but we did use the fact that S2 and R1 are equal to each other. All right, so that was important. We used that. Then we found other information. And remember, there is no higher grade or standard grade anymore. It's just pure maths. All right. So then what I said was, even if you can't prove these things that they're saying, prove that it's a cyclic quad, prove that the lines are parallel, prove that it's a cyclic quad, you can use it in the questions afterwards. So that's another nice hint, right? Even if you don't know how to prove it, you can use it going forward. And then, guys, another thing that's quite nice is to have some colors, all right? If you have some highlighters or even colored pencils, it's fine. It doesn't matter. If you are actually filling stuff in on the diagram, like circling stuff, putting in angles, I'll show you now the markers, putting in angles. Once you've proven that something or two lines are parallel, you put those arrows in. Right, guys, the diagram really is very important for you to, whatever you're finding, please put it in on your diagram. That's very important. Okay, someone was asking what markers I use. These are mild liners. I got them as a gift from one of my students that went overseas. Unfortunately, I don't think you can find them in South Africa. But I think it's Stabilo. They have pastel highlighters, which work just as well. It's just that these ones have like a highlighting end, and then they have like a marker end as well on the other side. So I tend to use the marker end. But you can just use any markers, right? It doesn't have to what's the word? It doesn't have to be these ones. Yeah, so time spent on mark allocation, that is also important. They did allocate marks here on the side, but guys, that is important. If there is a question that only counts 2 marks, please don't use a full 10 minutes to do it. Usually 2 marks translates to 2 minutes, give or take a little bit here or there. Sometimes if it's a long question and you're able to do it quickly, obviously you will buy yourself some time, but really you do want to, especially these prove that questions, because if it says prove that, for example, WO is parallel to TQ, all right, that is a 4-mark question, all right, which is quite a lot of marks. But now if you can't do it, you've spent already 4 or 5 minutes on it, move on to the next question, because you can use that going forward. Okay, it's not going to penalize you going forward. If you couldn't prove that they're parallel, you can then actually still use it. Okay, guys, I am going to sign off now. I hope that was useful. What you can do is, if you have more questions for me, you can comment on my videos and I'll try answer them. Or you can please go to my YouTube, guys. There are loads of grade 11, specifically lots of grade 11 videos. That's the grade that I have the most videos for. So there's a lot of paper 2 content on my YouTube. And then also there are lots of notes notes on my Google Drive. So there are full notes with explanations, with worked examples, with worksheets, with memos on my Google Drive. I really have a lot of resources that are completely free for you guys to use. And I really hope that it is useful. I don't have stuff on stats, unfortunately. Our kids did that under lockdown this year. There are notes, though. There are very nice notes on stats, so you can go take a look at that. And what I've also done, guys, for stats, for the calculator stuff, I have posted in the past. You'll just have to scroll down. I've actually posted videos where I show like step-by-step the calculator instructions, basically. So for finding the standard deviation, for example, I have a video on that. So yeah, I have a lot of stuff, guys. If you need anything else, you can also send me a message request on Instagram and I'll get to that ASAP. But best of luck with studying, and yeah, thinking about you guys. Have a lovely weekend.